Hello, everyone. Welcome to Northeastern University Seattle campus and the final presentation for the Advanced Software Development class, which has had three sections, one based here in Seattle, one based in Boston, and one based in Silicon Valley. So the project that the class has been working on is called Truthtree, and we're very happy to have the originator of this idea, Greg Shundler, here with us today in Seattle. So you may get some questions off Greg as we go through. I met Greg through an organization called the democracylab.org in Seattle, and there's a number of really exciting projects being hosted there, and hopefully the university can get involved in more than one of those. Anyway, I'm going to hand over to the class to give you a demonstration of the technology that's been built and then a description of how they've built it and what the future might look like. So without further ado, over to you guys.
Thank you, Professor. My name is Sheila, and today let's walk through what we did over the past 4 months. And before we get into the product as such, let's see what problems in society are we trying to solve. So basically, there are a few groups of people who think that a public spending does not impact our society in any way, and there are other group of folks who thinks that it makes an amazing impact on the society. The basic difference in opinion may be because that there is no single source of truth for the data as such, and we should try fixing that gap. And also, when we are in a location, for example, I'm in Boston, and I'm very concerned about problems in Boston location as such, and I don't really know about what's happening in other parts of the states. This might be a gap as well, because there are so many locations like Boston which can be facing similar problems, and they might solve these problems in a more efficient manner than we do. So if we have access to this knowledge base, our problem-solving nature will be more efficient. And also, a presence of these data sets are just not enough, but we need some data visualization tools so that a layman like you and I can very easily access these and see what's happening around the world. So for solutions part, of course, first and foremost, we need to unite all the public data sets and have a single source of truth, so we can have a dialogue with public, or even the policy makers as such, to know where our resources is being spent and where it can be spent better. And also we need tools to analyze these data sources. So what is Truthtree and how are we solving this problem? Truthtree is nothing but it's an interactive data visualization tool. I'm pretty sure each and every one of you have used Wiki. It's similar to Wiki, but it's just that it's not text-based, but it's data visualization-based. In Truthtree, we provide the user to access and dig into the data in a contextual manner with respect to the location, or with respect to the sector which you are interested in. For example, construction or hospitals in a particular location. And we do visualize these data in form of charts and table. So for this first release of Truthtree, we are using data from US Census Bureau, which gives us census data of the United States from 1967 through 2016. We only concentrate on local government spending in the United States, specifically for state, county, and cities in this release. Our long-term goal is to make this worldwide and further include satellite data for population, etc. So without further delay, we can just have an overview about what our application is and what are the functionalities which we provide user in this release. I request Jala to give a demo of our application.
Thanks, Sheila. My name is Jala, and I'm currently staying in San Francisco. And I've noticed that the condition of the libraries here is not so good. The buildings seem to be in pretty bad shape, and they look very old. So I love reading books, and I'm sure that a lot of people around also like books. So I'm not quite sure what the reason for the poor condition of libraries is. So let's investigate and see what's wrong. So to find out more, I come to Truthtree.wiki. This is our homepage. And I can enter the name of my city. And I get a list of options, and I select my city, and I go to a tabular view. So I can see names of cities here and populations. So I get a list of cities which are similar to my city and are in the range minus 25 to plus 25% of population. I can always change this range and increase or decrease the cities. Yeah. And I can also change the year to select what I want to see. So now you see, this is San Francisco, and San Jose has a pretty similar population. Now I want to see what is happening with the library spending. But before that, you see a left panel on the left side, right? So you'll hear a lot of terms like collections and attributes. So collections are basically outer grouping or containers of objects, and they're divided into more modular fields called attributes. So this goes into more detail about that collection. So I want to know more about libraries. So I just search for libraries. This comes up here, and I click on construction because I want to know how much we're spending on construction of libraries. Okay, so we're spending around $400,000 for San Francisco, but we're spending almost $8 million for San Jose. That doesn't seem right. Do we have less expenditure, total expenditure? Does our budget not allow for that? Let me just check. So what's the total expenditure? Well, we have a much higher total expenditure as compared to San Jose. So I'm not sure why this low construction cost comes from, where it comes from. So if I sort with respect to construction, our city is somewhere here. But if I sort with respect to total expenditure, I see that we have the highest total expenditure. Something's clearly wrong. Let me just click on this and see if something's happening. Okay. No, I don't find anything. I couldn't understand. I did go through everything, but I don't find a reason as to why this is so low. So was this always the case? Let me go to the time series view and see if, the cost of construction was always so low for San Francisco. I see these graphs, but there are so many of them. It's so confusing. Let me just deselect everything and just keep San Jose and San Francisco. Go away. So yeah. So I just see two here. So I see that the construction costs, expenditure for construction was pretty high in the 90s for San Francisco. And now it's literally zero. But if you see the cost, total expenditure, it's almost exponential for San Francisco. So I don't know where this is being spent. And frankly, I want to find out more and share this with my friends. So let me create a story. I type in something and okay, but I forgot what the name of my similar location is. So I come back here and I see that all my details are still saved in the story component. It does not go away. So I can type in my story, but I want to attach the picture. So what I do is I expand the picture, I download it, and I'll be attaching this to my story. So I have already pre-filled the story here with my name and the title. So I can add tags for the story, saying library, pending. This helps for the easier to search easily. This helps the user to search easily. So I can insert an image here. So go to my downloads, open this, and I've inserted this here. So there's a CAPTCHA, and this does not allow robos to submit the story. So I just click this and I click submit. And now my story is submitted. I just need to wait for an admin to approve my story, and then all my friends can see that. Meanwhile, let me go to other stories and look at them. Okay, this looks like an interesting story, Colorado interest rates. Let me upvote. Okay, upvote again. I've already previously upvoted, so I'm not allowed to do that. So I can browse stories. Meanwhile, the admin goes to his screen, types in the password, and comes to my story, which is here. Yeah. And he has an option to approve, decline, or delete the story. So let me approve the story. Now, when any user comes to the story section of our truth tree, they can see my story by sorting most recent. Yeah. Okay, this is not the one. Yeah. So yeah, this is my story. So they can upvote the story and then share it with all their other friends. So it's not just library spendings. Our application has a lot of other features. For example, if I don't know where a certain city is, I can always type the city and then click on one of these markers here to go to that particular location. So I want to go here. So, okay, unfortunately, this does not have data, but we can use the markers on the screen to actually select data. We also have an advanced section which uses fancy machine learning APIs to find similar locations with respect to different attributes or features and not just population. So if I select, for example, Seattle and select some attribute like debt and select a normalization and start year and end year and search, I find a list of all cities which are similar to Seattle. I can use this data and do some further investigation and learn more about it. So this is it for our application. I hope that this tool helps us all to understand different places better and find out the truth about everything. Thank you so much, and back to Sheila.
Thank you, Jala. I'm pretty sure that each and every one of us have like hundreds of questions about public spending, and libraries is just one of the examples. You guys can go back and dig into our application and see if our application answers your questions. So, of course, for such an amazing application, we do have a sturdy architecture. Just going over the overview of the architecture, Truthtree contains 3 layers. First is the client layer, which is nothing but the user interface which you just saw. Second is the service layer, which connects our user interface with that of the database, which contains the data set which we previously told. Our data layer is divided into 2 components. One is the machine learning, and the other is database. Database we have categorized and cataloged data from the U.S. Census Bureau for easy access and quicker access. And machine learning services provide us the similar search, which we just saw. This digs into the data and it gives us a deeper insight on the data which we have. Let's go over to the individual components of Truthtree and learn more about how we implemented it and what were the challenges which we faced and how did we overcome it. Firstly, let's go to Steven, who will explain us about the user interface component of Truthtree.
Right. So, hello everyone. My name is Steven. So I'm going to talk about the UI component of Truthtree. So what you're seeing right now is our front-end tech stack, and our front-end is codenamed Cassiopeia, and I would frequently refer to this name as we go through the presentation. So we use Node.js, NPM for bundling and compile our code. We rely on React and Redux for front-end development. We use Bootstrap 4 and SCSS for making everything more responsive. We also test our front-end with Jest and Enzyme. Our maps are powered by Google Map API. And you can see we have we are open source project, so you can go to GitHub and check out our source code. But let's dive in a little bit deeper on each component of our front end. So React is our choice of front end for the Vue development. So it's from Facebook, comes with its own markup language. Our goal was to easily create reusable components. So and React is a very good framework to do that. It's very fast. Doesn't do re-rendering every time the DOM changes. It utilizes something called virtual DOM, and essentially do difference between the real DOM and virtual DOM, and only apply the difference to the view. So it also have a very simple way to flow for the data flow. It's just one-way data flow. It has great support and documentation from version 16.2 or something. It got rewritten, so it's pretty much fully backward compatible, and it's much faster versus compared to something like Angular. That when you go to from version 1 to 2, it's lost compatibility. It has great developer tool, come with Chrome extension, so we can easily tell what's going on. So our app is a single page application. Each page essentially is a large component that contains multiple smaller components. Okay, can you please go to the next slide? So about Redux, we chose that because it enhanced the one-way data mining for us. So as we enforce the pattern, it's easier to step through the state history. It also comes with a lot of support tool. So we utilize both local component state and global Redux state. And you can see on the left, something like a drop down should be open or not. It's a local state. And on the right, you can see how the search box interact with the map. That would require something like Redux global state. So we use both of those. For the next part. So about our development process. So as I said, Truthtree open source, so we aim to make everything very straightforward. So we use NPM for the dependency management, and the whole project comes with local development server so that it are very accessible. You can use localhost, or you can use your phone and access it through a local area network IP. So in case you want to test with your phones or something. And as you make changes, the browser should refresh itself to reflect the new changes. So it have speed up everything. So sometime you would have to develop API endpoint and front-end UI change at the same time. So, but by default, our project point to a staging server, which should have the latest code. But if you wish, both Cassiopeia and backend services can be run locally so that you can develop the features that require UI changes. It's just as simple as coming to the package JSON and change one line. So for pull request and code review, we for each pull request we require code review and approval. Each of these would have to run through a Travis CI, which in turn runs things like unit test, integration test, and it also tests the ability to generate a production build, which ensure that it won't affect the backend build because we build our front end alongside with back end every time there are new code coming. A temporary Heroku instance is also generated so that reviewer don't have to run the code locally and they can see the changes live. And that's it for the UI component. Now back to Sheila.
Thank you, Stephen. So next, let's move on to the service layer of Truthtree. I request Neha and Amit to present this part.
Thank you, Sheila. So Stephen explained what a client layer does. I'll explain what a service layer does in the entire Truthtree architecture. So it's a connection between client and the data. So just to give you an overview, it acts as a standard way of taking a request from the client and consuming the information from the client, requesting the same information to the different data layer applications that we have developed and giving back the response. So it acts as a standard way of having a middle layer in between the entire application. It provides you the extensibility to consume different microservices. So for someone who doesn't know what microservices does, it's a way of creating independent component-like services so that you can easily plug in between the applications. So for instance, we created stories as a separate microservices. So now the client doesn't have to worry about what exactly story is doing. It will still request what a service layer has developed, and the internal working can be done independently. So this gives us a flexible way of adding more services in the future. It also gives you a security. So whenever a request is made, we check for the admin access. So if a user who is responsible for seeing what exactly requesting the data is given to, if a user who is requesting some information is allowed to see that information, we process the request. Otherwise, we just return back the failure. And the last thing is it's a single source of truth for the client. So whatever client knows about the Truthtree backend, it's what the service layer does and provide. Next slide, please. So this is the overall architecture of the service layer. So it starts from the controller component. So if any request is made, we accept it as at a controller level. Controller passes the request to the service where the entire business logic of the application resides. So if we have to authenticate someone, if we want to check the login and access, so we do that at this level. We also do the normalization part, which is basically giving the response in the format of by population or by revenue. When everything is acceptable, it processes the request and gives further to the adapter layer, which is basically responsible for communicating with the external layer of the application. So for instance, we have the data layer on the right side. So for different layers, for different data sources, we have different type of adapters. DB adapter calls the DB services, which is responsible for storing all the information of the government finance data, processing it quickly and giving us the response. ML adapter calls the ML microservices. So whatever the advanced machine learning stuff is done, we get the response from there, and ML adapter returns the same response. We also have a mock adapter, which we use for our local development. So whatever we have, we want to see if the application is returning something, we use this adapter for the development. So whenever we get the response from these three data sources, we process it in our own format using assemblers, which converts it into Java object. Also, we use jolt mapping, which if we're not using any kind of a DTO, so for the attributes processing, where there are so many attributes to do and handle, we use jolt mapping for quicker and faster way of converting the response in our own standard format. And then whenever we get the response, we send it back to the service, and then service gives back to the controller. Next slide, please. So this is a sample sequence of action when a story has been created by a user. So if you see the story service object, whenever a user requests for the story service is basically where the service layer resides. So it sends the information to the DB layer, which is the DB story service. DB layer stores the information in the Elasticsearch database with pending status. So user will know that the story has been saved and it is waiting for approval. We go to the next slide. We see what exactly admin does and what exactly our admin access check is doing at our level. So whenever admin logs in, it calls our login service. We authenticate if the proper password has been provided to us. If the login session is maintained, admin will call for all the stories. At the story service level, we check for the admin access. If it is correct, we pass it to the DB service. Otherwise, we send the failure as an unauthorized access. Similarly, for the next call, if the admin access is correct, if the stories were returned successfully, which were having pending status, we call the approved. If admin can approve, decline, or delete the stories. So for that also we check for the admin access so that anyone else doesn't approve if it is not authorized to. And similarly, the request is sent if admin access is done, and it goes to the DB service, and the status is updated by approved, and the response has been sent. So next part will be explained by Amit. So this is what the tech stack we have used. So I'll be passing on to Amit for the next explanation.
Thank you, Neha. My name is Amit, and I'll be going over the technologies that we used for developing different APIs and services for the client layer. So we are using Java to implement the APIs or the services, and on top of it, we are using Spring Boot framework. Spring Boot basically have everything that we required for implementing our features, but on top of it, we used Apache Maven. So Apache Maven is used to manage all the dependencies that we required for our service layer, and it's one of the best dependency management tool. And there were situations where we needed to convert one object to other. Let's say converting from one Java object to JSON object and vice versa. So for that operation, we used Jackson. And also, we believed in developing the services in a test-driven manner. So whatever services we were developing, we were writing unit tests and the integration test for that, so that the services that we are building will be robust. So for that, we used JUnit Mockito for unit testing, and for integration testing, we used TestNG. We also came across situations where we needed to convert the responses coming from the database layer or machine learning services, and for that we used Jolt. Can you move to the next slide? So as Neha explained, we are acting as a middle layer between the client and the backend services. So whatever the services were provided to us from the backend side, we consolidated all the services in our service layer. So some of the supported APIs that we implemented are collections, as Jhala demonstrated earlier. Whatever was on the left side of the home screen, they were the collections, and you can search for a collection based on a location or an ID. You can also search for different attributes for any number of locations, giving it a year value, and you can get it in a normalized way, let's say by population or by revenue. We also developed some APIs for basic information of locations. Let's say if you want to search some information about Massachusetts, or you'll get it with through this service layer. And we also implemented the services for the stories. Let's say if you want to create a story, or if you want to read some stories or if you want to search for a particular story related to a particular location. And all the advanced ML machine learning services that were provided to us were also implemented in this service layer. Similar location search and location type ahead search were also implemented. So that's all from the service layer side.
Thanks so much. So we did see what our service layer does. Next, let's move on to our machine learning team, who cleaned our data, and they have spent their time and energy in working for similar places. Let's hear from Lohitt and Apar what they have done over the past 4 months.
Hey everyone. So the main purpose of machine learning part was to provide similar places. Now let me first explain what do we mean by similar places and like why would a user need them. So every student on this campus is doing masters. We can say that we are similar in that context, but every student also like had a different path in their life to reach here, right? So including that path makes more sense when we talk about similarity. Putting it into the context, so let's say you want to find which states have similar education expenditure like to your states. Now you can compare it with any other state, but maybe the other state have a very high revenue, that's why they are spending more, or maybe they have a very low revenue, that's why they are spending less. So it makes more sense if you, so let's say you decide to compare only those states which have similar per capita revenue to your state. Now, how do you know which states have similar per capita revenue to your state? So we tell you that. We provide 2 versions of similarity. One, where you ask for those places. Jala, can you go back, please? Sure. Thank you. So we give 2 versions of similarity. One, where you give the list of, where you ask for those places which are similar based on a pattern of a particular attribute. For example, you want something which has the same value for last 20 years or last 40 years. Another version is where you ask for those places which have similar values for multiple attributes for a single year. Now, how do we do that? Can you go to the next slide? Before I proceed, do you have any questions on the use case side? Okay. So how do we do that? So this was the original raw data that we have. So IDs are one place. So for each place, we have so much data per year, right? So we first converted into this format where we have for each place, for each attribute, we have these many years. For next attribute, we have a list of attributes. So we converted into this format. Now, once we have to this format, next slide, please. So once we have this format, then based on whatever version you want, if you want single attribute and multiple years, we convert, we only take that particular attribute, or we can take one particular year for multiple attributes. So based on whatever you request, we convert into that. Next slide, please. So once we have that, let's say you ask for total expenditure for over from 2000 to 2050. So let's say this is the place that you ask for. So we have now data in this format for all the places. Now what we do is we take the distance of each column, between each attribute for each column. We find the mean distance between each place. We sort it based on that, and we give you the top 10 or top 15 or top 5 results, whatever you ask for. I have an example for this. So in the advanced section, let's say I look for the places similar to Washington based on the total revenue, per capita total revenue from year 1980 to 2016. So it gives me these are the results where New Jersey is more similar than Maine, than Montana, than Ohio, than Pennsylvania. Now, how do actually, we are giving you the list, but how do you know if they are similar? So I plotted a graph between New Jersey and Washington, based on what we are seeing, and these are the patterns. So when I talked about the master's students have a different path, so this is basically capturing the path. And so, now you have the states which have similar path as yours, and then you can compare different things on that. Now Lohitt will explain you the other details.
All right.
So essentially what Apar explained was how we use different data analysis techniques to find similar places, right? So now let's see how we provide it as a service. We have a database generator, which is responsible for creating the tables in Postgres from the pre-processed data. Then once we have the database up and running, our service will read the tables in the database and convert it to a format which was explained by Apar. Once we have done the pre-processing, the server is now ready to accept the connections from the UI layer. When the user wants to find places which are similar in certain attributes, let's say general revenue, it comes through, it originates in UI, comes through full stack layer and reaches the machine learning as a service layer. And our service, our REST API service will handle this request and it will apply nearest neighbor algorithm dynamically and forms an HTTP response from the results of the algorithm results, and this is then sent back to the full stack layer from where it will reach UI layer, and the user is the UI will display the list of places which are similar.
Thank you, Rohit. Next, let's move on to the DB component of Truthtree to see how we categorized and catalog the data which we obtained from US Census Bureau.
Hello everyone, I'm Akriti and now I'll talk about our database implementation. Our data is currently deployed on PostgreSQL and Elasticsearch databases on AWS. So first of all, let's take a look at the data set that was prepared for the project, that was referred for this project. The picture here is just a small snapshot of the data file that we had. The file has almost 50 years of data for all states, cities, and counties of the United States. So along with location information like year, ID, state name, and parent location, this file also provided us values for attributes like population, total revenue, earnings, expenditures for various departments. And these departments could be transport, education, retirements, utilities, health, licenses. So what I'm here trying to convey is that how powerful and diverse the finance data set that is provided to us is. But since the data set has over 579 attribute values, along with null values and data for 50 years for all 3 location levels, we had to design the database in such a way that it is efficient, uncomplicated, and it is flexible for updating new attributes and data in future. So this was challenging, as it would have been tedious if we had just created the database as it is given in the CSV files. So I'll talk about the database implementation now. As to make the data more visible and to enable us to make specific analytics out of the data, we divided the attributes into collections and properties, as was shown by Jala during the demo. So here's an example of elementary education total expenditure, which we divided into elementary education as the collection and total expenditure as the property. So we identified 85 total collections, and each collection had almost 5 to 6 attributes. And as you can see in the diagram, we have 5 tables. Government field location info has location specific data. Government field lookup has value for attributes, which are divided into collections and properties. And then we created indexes on all these tables. The next part was creating APIs to retrieve data. These APIs are called by the full stack layer for presenting on the UI. Since the data is huge, to avoid memory issues on front end and as the back end and ensure faster retrieval, we implemented pagination while returning the results, and we also cached the page information per request with same query conditions for 5 minutes. So next, I'll talk about our Elasticsearch mapping for stories. We used Elasticsearch database for managing stories submitted by the users. So Elasticsearch gave us properties so that we can do operations like upvote, downvote, creation, and deletion of the stories. We also created endpoints for searching the stories by title, tags, and author. Elasticsearch gave us the flexibility to write fuzzy query logic for searching instead of the exact matches. But while we were working on Elasticsearch, we faced an issue. Since Elasticsearch is not transaction safe, that there was an inconsistency while uploading and downloading. So to solve this issue, we implemented message queuing system. So what happens is, when we receive a request for updating the fields, the request will be inserted into the message queue, and the program will extract 50 messages from the queue every 15 seconds. So that is how we resolve this issue. So next slide is an overall architecture of the backend. As you can see that we provide a REST API as an endpoint, which is called by the other teams and we provide database as a microservice. So, and to query the data in many ways. We get this data from government DB, which is a PostgreSQL DB, and Elasticsearch database has the stories, and we get these via various layers of controllers and services as shown in the diagram. So now I'll give the control back to Sheila.
Thanks, Akriti. So next, we did go over how we have built Truthtree, but it's also important to know how we have deployed and how easily users can access our application. Now Aaron will be explaining about the deployment process.
Yeah, so with deployment, everything basically starts with the GitHub, either a push or a merge in GitHub. I lost control. So once a push occurs, if you could just mouse through with me, sorry, there's some animations. Once a push or a merge occurs, our pipeline will kick on. So we have Travis CI is the service we use for that. So Travis CI will then run our tests, which were talked about earlier. They're JUnit and TestNG, JUnit for modular tests, and then TestNG for actual live integration tests. Once those pass, then we'll go ahead and Dockerize the code itself. And once that is Dockerized, we'll perform a tag and push to Amazon Web Services. So first, within AWS, we utilize the ECR, the Elastic Container Registry, which integrates closely with the ECS, which is the second one there, which is Elastic Container Service. They love their acronyms. And once it's passed with ECS will push to the ECR, or EC2, which is the Elastic Computed Cloud. And that will actually run the application, which allows you to access the website. That's all I got to say.
Thank you, Aaron. So to make it user friendly, we have created a few documents which will aid utilization of our application. We have an open source code base, which is nothing but github.com Truthtree ASD, standing for Advanced Software Development, and we have user guide which in detail explains with screenshots how to navigate through our system and all the functionalities which are available. And we have admin guide for the users who moderate the content, that is to approve, decline, or delete a story for now, but this can be enhanced in our future releases. We have release notes covering all the features we have incorporated in this release. We also have a list of known issues. We ideally wish we could have fixed them, but we do have certain known issues left. We have DevOps Runbook if anybody wants to learn about what the process is all about. And we also have a future work document which says what enhancements can be done and what new features can be added to Truthtree in the near future. Thank you, everyone, for listening through. I open the stage for Q&A.
Okay, thanks, everyone. Any questions from the distributed audience that we have here? Greg, do you want to say anything?
I'm amazed by what you guys have accomplished. A lot of this is way over my head, and it's very powerful to think of this data set alone, but then obviously contextualizing it with other data sets, and that you guys have developed this in a way that others can build from it and made it open source and shared it is pretty incredible. I'm kind of curious what people's thoughts are for what to do with this in the future. And, you know, I don't know what they thought about it or applications or how they might want to improve it and things that they saw as well. Having been so intimately connected with it for, what, 4 or 5 months now.
I think if this tree is to grow, the next step would be to implement easy-to-use social share features so that it can be used with other platforms with the touch of a button. Post to your favorite social platform like Facebook or Instagram or Twitter, whatever have you.
Yeah, I think that would be a great feature to have, actually.
Yeah. I also think work on the login, user login part. So yeah, each user will have a list of liked stories, and they'll have their own profile about the stories they have written, and they can set their interests and get notifications if someone writes a story about that particular interest.
Yeah.
Exactly. Yeah, some way to branch trees so that if you disagree with someone, you can tag their original post. And then, you know, there could be an admin function that kind of curates this in a way that Wikipedia does so that you don't have to go through 15 different debate articles. You basically get the main points. But those could even be published meta stories that, you know, curators put together, you know, once a theme like libraries is figured out or something like that. Yeah. So what else? What else did you guys think of? Like, I can also share, like, not knowing what you guys know how to do. My approach is to continue to engage student groups where possible, and then do thematic modules. So the next module would be this global data set for carbon emissions. It comes from a raster data set for the whole planet, and I can process it by, I've already made data tables by watershed, administrative units, national, state, county, urban extents, whatever. And so they could bite that off, and then maybe the next person does health metrics that we have by city, state, and county, and then the next person might do economic data, employment sector, whatever it is, and just basically grab one solo at a time of public data and weave it in. And so my question would be, if I do that, what do I need to do to acquaint those teams with what you have done? And is there a threshold for their skill level where they might be better off developing a module independently? Or what do they need to do for like another DB to be ingested and then have all the same functionalities of search and, you know, the machine learning curve and so on?
So, Greg, I think we have everything documented in a developer guide, which we will definitely share. So I think it's pretty extensible. So if we have another database for these different modules, and our full stack API can consume the APIs from the different databases and provide like a common interface, which can then be used by our UI to display different things. So if the database is ready, I think it should just be passed through APIs on the full stack layer. So our current implementation can be extended to accommodate that.
And what about front-end features? If someone, for example, wanted to make bar graphs out of the table view, or they wanted to, bring in a mapping visualization or something like that.
Yeah, so it's open source, so they can anytime clone the repository and just contribute. And there's also a user guide and documentation about what we have done on the front end, so that should give more or less a clear picture as to what we did then.
Yeah, I would think incorporating bar graphs as an equivalent to the table view would be pretty straightforward, actually. I mean, that would be a good exercise for someone to do to acquaint themselves with the front end. Yeah, that shouldn't be hard to do at all. Yeah, it's just a matter of whoever wants to contribute to dive into the code, look at the documentation that the project has written, and maybe take on a small improvement just to get used to the actual code base. And then once they're used to it, they can look at more sort of powerful extensions.
And something I've been trying to do too is get user groups together. So last weekend there was a climate conference in Olympia, Washington, and there was one student paired with basically one elder from the community, and they looked at comparable geographic entities and they fished out solution stories by theme, rooftop solar, electric bikes, and this and that. And they really enjoyed the exercise, the user group. So part of what I would do too is also bring this platform to user bases. So say there's and I hope that Democracy Lab is able to do that, especially in Seattle, but also beyond, that if there is an NGO or a community group that's concerned about police or homelessness or, property taxes, property tax defense group or something, then they would be some of the first people to test as users with, and then because they would have the motivation to go out and then cross the data with other content in the internet. For example, the New Jersey and Washington State thing, one thing we noticed with the downturns is that New Jersey, their revenue stream has been more robust in terms of recession. And so then then I just easily Google image how New Jersey gets their money, and it's way more property tax and income tax based than sales tax based. And then there's a huge literature that corroborates that, PDFs and white papers and plenty from the academic community. And so that's the kind of weaving together of the visualizations that you guys let users make with what they're finding on the internet anyway. And so it's pretty interesting. You can be one step away from a find that way. I guess one question would be, in terms of open source community, I don't have that much experience. Should I be sending this out to certain people, or how do you really start engaging an open source community?
Maybe the first step would be to advertise it on the Democracy Lab org here in Seattle. That may attract some developers who are interested in extending this or building on it. I think it's going to come from your communications and our communications to the community. People see the potential of this type of tool, and then maybe they'll get engaged. I think
there's a potential in the Northeastern community, like around the world, to engage computer science students on other campuses or in the future.
Yeah, I mean, that's certainly an option. We could look at continuing projects either based on this platform or extending it to some sort of, more raster-based technologies that you're talking about with climate data. So I don't see any reason why that can't be investigated. Because I think most people on the project had fun most of the time. So
that's good news.
It was challenging.
I'm worried about that.
No, it was challenging. I mean, the data set was challenging. The understanding the requirements was challenging, and there's a lot of technology in this thing that they've got used to and built. So it's been really good.
I'm curious how the students, and it comes to the students on what it was like to work in this team virtually with other students from different locations, and that whole experience. Anybody want to comment on that?
that was kind of more of a challenge than like if someone is there, you can meet in person and, for example, talk more thoroughly about things. Like talking virtually was kind of like especially like with different time zones, it was like more difficult. So it was fun, but it was something like that added to the challenge. And fun aspects.
But I think we got used to it pretty soon because we met at regular timings every week. So we had, in addition to the class, we had like stand up and where we caught up about the week so we actually met 3 times in a week, once during class and 2 other times on our own. So we made sure that all of us knew about what each other was doing.
Thank you. I have a question. So there's a lot of process in what you do, right? And obviously there's a lot of process with what you did. And so it was embedded in the integration and how it's open source, and you have to in a large team like this. At what point did you? Obviously, that's a burden as well, right? To add so much process in there. We know why you do it. I'm sure Ian's told you why, but did you feel like it was worth it? And like, I guess, do you have an example of when you felt it was worth it? It was not just a burden.
Like at least like the first 15 days, like basically when you understand what a product is and like how impactful it could be, that is when like we got to know that like what we are doing can make a difference. Right? So for example, I can talk about my part. So like at least for the first month, we didn't have a specific goal. So like we were still like figuring out what we can do and what we can add. But like once we got to know that we have to find similar places, and we came up with the use cases, and once we know that how it can help the users to figure out what exactly they want, or to how they can help the users to create stories. So when you realize that, that's when you know it persists forward and more of a fun thing.
Another example I have is unit tests. So we used Enzyme on the front end for writing a unit test. And when something was breaking in the last minute, it kind of felt it's easier to just comment out the test and go ahead with the actual implementation, because I know the code works. It's just the unit test which is failing. So I think we did at certain times slack off on the test part, but we realized towards the end when a lot of things were breaking, it would have been much, much better if we had been more strict about that.
Yeah, I think the team actually did a good job in breaking the project up into sort of emergent requirements, because Greg had a vision for this product in his head, and it took us a while to extract it. It's not surprising. And also the data set was complicated. So the database team to start off with had to, iterate over the best way to organize this data. And there was 2 or 3 attempts at that before we got something that seemed reasonable and also reasonably fast. And so while that was happening, as has been described, the machine learning team kind of explored the data statistically to find out what was possible. And the UI team threw together some mock-ups, and it all slowly came together about the middle of the semester. So I think the team actually did a really good job with coping with the kind of the uncertainty of the project. So that was really good. Okay, let's stop the recording now. Thanks, everybody. Well done.